How are you guys? Today we're still at fluid mechanics N5. We're doing compressibility. I want us to look at this topic, compressibility. Okay, what is compressibility? I've written down here is the degree of compressibility of fluid is shown by its isothermal bulk modulus K. Okay, we know what I'm trying to say. Let's say I have a piston here, and in this piston it's inside it is inside of the cylinder. Okay, here it's our cylinder here. We know here will be have some gases here. So when this piston, when I apply the force here, maybe say I apply the force here, maybe 500 Newton, this will cause the piston to go upwards. When it's going upwards, the degree which this piston compress this air, this gas here, this gas, remember also gas is a type of fluid, this gas will, this cylinder pole will move, maybe somewhere here, this compressibility, because it's gas. So that compressibility is its symbol, it's K, which is modulus. It's isothermal bulk modulus, which is K, is represented by K. We want to know how much does this force compress this gas here. Will move when I apply, will move like this. Will compress this gas here. How much? Yeah, like the pressure that when I apply the force, how much the pressure that the gas also will exert on the piston. Want to know that compressibility is indicated by letter K, which is isothermal bulk modulus. Okay, its isothermal bulk is represented by K. Okay, and then this K is measured, almost of the most is measured in Pascal, but always will be gigapascal, something like that. Often it can be megapascal, but always, most of the time, let me not say always, but we will have to convert it to gigapascal. Okay, so let's say now there's this. Okay, let's say now we have here, I have some, this is the length from here to here of this. Okay, let's say from here, let's say is 2 millimeter, that distance. Is maybe I have K, which is maybe 1.9 gigapascal. Maybe I have diameter here, can say is 20 millimeter. You see, so the question can say calculate the volumetric strain. I want to understand that the volumetric strain in strength of material, or in strength, you know that usually strain in strength is equal to change of length over change over original length. Usual strain is change of something over its original state. So simple again, here it represented in fluid mechanic volumetric strain is represented by capital eta E. Then here down there you will write whether you are calculating volumetric strain or length strain. Is depending on which strain that you are wanting. If you want volumetric strain, here you will write small letter V. Remember, volumetric strain, I said strain is a change of something over its original form. It's a change of volume over its original state. You see, then this is a volumetric strain. Also, you can have, also this thing is equal to pressure, which is P, ne, over K. We must put this in mind. Any strain, doesn't matter which strain, it can also be like, I can say also like this. I can also say strain of the, maybe I say L here is a stress, will be changing length over original length. We know this is the strain again, is also equal to P pressure over K. Same thing here, pressure over K. You see, all strain usually, then I can simply erase this. That means, you see, change in length is equal, over change in length over original length is equal to P over K. Change in volume over V is equal to P over K. You see, always is like this. This K will be given, which this K, I know this K is isothermal. Don't make mistake. Will be written on question paper. It's isothermal. It's isothermal bulk modulus. This K is bulk. Also, here it's the same thing. This K will be given on the question. So, do not make mistake. This will be given. So, in other words, if I want a change in volume example, I can simply say change in volume is equal to P. I make this subject to formula. Maybe I use this on the top. Will be pressure multiplied by volume over K. You see, same thing, same applies here. I want you to understand this. And then remember, this K is isothermal bulk modulus always. And then will be given. So, to break this further, you can be given, again, this thing that we have to discuss, which is called effective bulk modulus. Effective bulk modulus. Okay. Now, effective bulk modulus, we must understand it also. Is different from this. You see, the difference, this is isothermal. This is effective. This is not the same thing. Isothermal will be always be given. This can be given also. Some often you calculate it, but also can be given. But this is effective. It's not the same as isothermal bulk. Please remember that. Do not confuse the two. Isothermal bulk is defined as follows. It's when force is applied to the piston of the cylinder, of a cylinder filled with liquid. Then there is a spring effect or a play is experienced, that is experienced on the piston, will be experienced on the piston, obviously. Okay, effective bulk modulus, it's when force is applied to the piston of a cylinder filled with liquid a spring effect or replay is experienced on the piston. This is maybe the factors. This might be due to the compressibility of the liquid, compressibility of the air trapped inside the liquid, the expansion of the cylinder wall. We know, let's say I can draw here a piston. Here it's a gas here or liquid, will depend. The force that applies the force when I apply the force here, when I compress this, remember there will be this gas will try to push this piston upwards in the opposite direction, that we call the effective bulk modulus. There will be this gas will also applying. I apply the force here, maybe 20 newton of will cause this piston power, piston head, this piston to go in this direction upwards. Also, this gas or air that is trapped here or liquid will also apply force on the opposite direction, which is an effective bulk modulus. We'll call it the one that is applying to that. We'll want to push this. Since you want to push this will cause the play here on the cylinder head, on the piston head. On the piston will cause the play. There will be a play due to what? When I apply this side, also this gas that is trapped will try to oppose what the force that I've applied. You see? So that we call it effective bulk modulus. And then there's a specific formula to calculate it. The formula to calculate effective bulk modulus, the formula to calculate effective bulk modulus, its formula will be given as 1 over KE, which this is an this K effective is represented by K with letter E here. This is the effective bulk modulus. Then its formula is equal to 1 over KC plus 1 over K, that one is L, plus V gas over V total into 1 over KG. This is the formula. When you want K, you reciprocate. When you want to calculate this, you reciprocate. You take this upwards. Also, this answer, you take it upwards. Then you find what K. Which this K, remember this K that we are looking for, it's an effective bulk modulus. This KL, this one, it is an isothermal bulk, will be given this one, isothermal bulk modulus. Yes, the question can say calculated, but it will be rare. It's rare to calculate it, but this is do not confuse the two. This is the same if this K. Remember, isothermal bulk, I said is this K here. It's pressure over this. This is a usual, I can say L here, little L. Can say L so that you cannot be confused. Can come here and say KL. Remember, I said P over isothermal bulk is equal to usually is equal to what? Strain. Strain can be a volumetric strain, length strain, any strain, but is equal to pressure over isothermal bulk. And in this isothermal bulk, it is KL here on this formula. This is an effective. Do not make any mistake here. Then we have this KC here. I want us to decide about this KC. This KC, we must know what is this KC. This KC is always, it has its formula. This KC is equal, you have to remember this, KC is equal to Young's modulus over 2.5. Always is this is the formula of this KC. If you're given Young modulus, this is Young modulus, elasticity of Young modulus, this is the Young modulus. If you're given Young modulus, if you're given Young modulus, you substitute it here and then you obtain your KC. You see, now we come to this part here, this one, Vg over Vt. This is it is a gas in the system. This is the total volume of that. This is a gas, ne? It's a volume of the gas, but this is the total volume. That means total volume. If I have a piston like this, I have a cylinder like this. Here is the piston. Let's say here like this. This Vt will be total volume of this piston, you understand? But this gas will be that gas, that percentage of the gas that it's inside of this cylinder here. I hope you understand it. So this will be given, or sometimes you calculate it, you'll make it subject to formula if it's not given. And then this, you write it in the form of decimal. Let's say they give you this, they say the air, it's amount of air. I told you most, the amount of air, percentage, or about maybe something said air, then maybe they say is 2%, example. But air in the system, this is an air in the system, might be a gas, maybe they say is 2%. If it's 2%, obvious, this is in percentage, you must use it to be in decimal, or you can use it, this is the same as 2 over 100. You see, this is the same as, this will be equal to Vg over Vt. You substitute this whole thing is equal to this whole thing. You understand? You will substitute this, you can write it as a decimal if you want, but when you see this, you will substitute this 2%. These things, all of this is equal to 2% because it's the air on of the system is included. What the volume is taken as in 100%. You understand it? Okay. So there's this kg here. This thing called K mol G here. There's mol G. Its formula, this one we must know its formula, which its formula is like when you have first is including the pressure, it's 1.4. This one is constant, or this 1.4 is constant multiplied by this is pressure, so that you can get this. If you know the pressure, you can simply substitute your pressure here and get kg. This one always like this will be given in the formula sheet, will be given maybe as this thing like this P. You know this represent, this is 1 over, or is 1.4, always 1,4 always. Okay, yeah, remember this is effective bulk. Kc is given by this E over 2.5. KL is isothermal bulk. This is a amount of is the air in the system, total air. This is kg. You know this formula. Okay, I hope you understood this, guys. We'll do some examples on the upcoming video. I hope you subscribe, you stay tuned so that you can be notified when I post a new video. Subscribe and like this video and comment. Thank you, guys. We will continue.